Hi everyone, this is Glenda Ganzon and welcome to my Human Anatomy and Physiology class. For today's lesson, I'm going to discuss the role of homeostasis in healthy functioning and to contrast negative and positive feedback, giving one physiologic example of each mechanism. Maintaining homeostasis requires that the body continuously monitor its internal conditions, from body temperature to blood pressure to levels of certain nutrients. Each physiological condition has a particular set point. What is a set point? A set point is the physiological value around which the normal range fluctuates. And what is a normal range? A normal range is the restricted set of values that is optimally healthful and stable. For example, the set point for normal human body temperature is approximately 37 degrees centigrade. Physiological parameters such as body temperature and blood pressure tend to fluctuate within a normal range a few degrees above and below that point. Control centers in the brain and other parts of the body monitor and react to deviations from homeostasis using negative feedback. And what is negative feedback? Negative feedback is a mechanism that reverses a deviation from the set point. Therefore, negative feedback maintains body parameters within their normal range. The maintenance of homeostasis by negative feedback goes on throughout the body at all times, and an understanding of negative feedback is thus fundamental to an understanding of human physiology. Let me discuss to you what is negative feedback. A negative feedback system has three basic components. Number one is a sensor. So what is a sensor? Sensor is also referred to a receptor. It is a component of a feedback system that monitors a physiological value, and this value is reported to control center, which is the brain, and that is number two, the control center. So control center is the component system that compares the value to a normal range. If the value deviates too much from the set point, then the control center activates an effector, and that is number three. So an effector is a component in a feedback system that causes a change to reverse the situation and return the value to a normal range. The picture in this video is a negative feedback loop. In a negative feedback loop, a stimulus or a deviation from the set point is resisted through a physiological process that returns the body to homeostasis. And a negative feedback loop has four basic parts. The body temperature is also regulated by negative feedback. In order to set the system in motion, a stimulus must drive a physiological parameter beyond its normal range, and that is beyond homeostasis. This stimulus is heard by specific sensor. For example, in the control of blood, glucose-specific endocrine cells in the pancreas detect excess glucose, which is the stimulus in the bloodstream. These pancreatic beta cells respond to the increased level of blood glucose by releasing the hormone insulin into the bloodstream. The insulin signals skeletal muscle fibers, fat cells or the adipocytes, and the liver cells to take up the excess glucose, removing it from the bloodstream. A glucose concentration in the bloodstream drops. The decrease in concentration, the actual negative feedback, is detected by pancreatic alpha cells, and insulin release stops. This prevents blood sugar levels from continuing to drop below the normal range. Humans have a similar temperature regulation feedback system that works by promoting either heat loss or heat gain. When the brain's temperature regulation center receives data from the sensors indicating that the body's temperature exceeds its normal range, it stimulates a cluster of brain cells referred to as the heat loss center. The stimulation has three major effects. The first effect is the blood vessel in the skin begin to dilate, allowing more blood from the body core to flow to the surface of the skin, allowing the heat to radiate into the environment. Number two, and the second effect is as blood flow to the skin increases, sweat glands are activated to increase their output. As the sweat evaporates from the skin surface into the surrounding air, it takes heat with it. And the third effect is the depth of respiration increases, and a person may breathe through an open mouth instead of through the nasal passageways. This further increases the heat loss from the lungs. In contrast, activation of the brain's heat gain center by exposure to cold reduces blood flow to the skin, and blood returning from the limbs is diverted into a network of deep veins. This arrangement drops heat closer to the body core and restricts heat loss. If heat loss is severe, the brain triggers an increase in random signals to skeletal muscles, causing them to contract and producing shivering. The muscle contraction of shivering releases heat while using up ATP. The brain also triggers the thyroid gland in the endocrine system to release thyroid hormone, which increases metabolic activity and heat production in cells throughout the body. The brain also signals the adrenal glands to release epinephrine, or what we call as adrenaline, which is a hormone that causes the breakdown of glycogen into glucose, which can be used as an energy source. The breakdown of glycogen into glucose also results in increased metabolism heat production. This time, let me discuss to you the positive feedback. So what is a positive feedback? A positive feedback intensifies a change in the body's physiological condition rather than reversing it. A deviation from the normal range results in more change, and the system moves farther away from the normal range. A positive feedback in the body is normal only when the definite endpoint. Let's say, for example, childbirth and the body's response to blood loss are two examples of positive feedback loops that are normal but are activated only when needed. Childbirth at full term is an example of a situation in which the maintenance of the existing body state is not desired. Enormous changes in the mother's body are required to expel the baby at the end of pregnancy, and the events of childbirth only once begun must progress rapidly to a conclusion, or the life of the mother and the baby are at risk. The extreme muscular work of labor and delivery are the result of positive feedback. The picture in this video is an example of a positive feedback loop. It is a normal childbirth which is driven by a positive feedback loop. A positive feedback loop results in a change in the body's status rather than a return to homeostasis. The first contractions of labor, which is the stimulus, push the baby toward the cervix, which is the lowest part of the uterus. The cervix contains stretch-sensitive nerve cells that monitor the degree of stretching, which are the sensors. These nerve cells send messages to the brain, which in return causes the pituitary gland at the base of the brain to release the hormone oxytocin into the bloodstream. So this hormone oxytocin causes stronger contraction of the smooth muscles in the uterus, which are the effectors. pushing the baby farther down the birth canal. This causes even greater stretching of the cervix. The cycle of stretching oxytocin release and increasingly more forceful contractions stops only when the baby is born. At this point, the stretching of the cervix halts, stopping the release of oxytocin. I'll be giving you another example of positive feedback centers on reversing extreme damage to the body. Following a penetrating wound, the most immediate threat is excessive blood loss, right? Less blood circulating means reduced blood pressure and reduced perfusion or penetration of blood to the brain and other vital organs. If perfusion is severely reduced, vital organs will shut down and the person will die of course. The body responds to this potential catastrophe by releasing substances in the injured blood vessel wall that begin the process of blood clotting. As each step of clotting occurs, it stimulates the release of more clotting substances. This accelerates the processes of clotting and sealing of the damaged area. Clotting is contained in local area based on the tightly controlled availability of clotting proteins. This is an adaptive, life-saving cascade of events. So this is it, class, our lesson for today about homeostasis, the role of homeostasis in healthy functioning, and the negative and positive feedback, giving one physiological example of each mechanism. And I hope you've learned a lot. And if you have any question, please write it in the comment section down below and I'll be glad to answer them all. And thank you for watching and for listening to this lesson or lecture. Until my next video, God bless everyone. Bye.